So I'm going to talk about Arvos today. It's a way of tracking vulnerabilities in an executing environment. And this has been a collaboration between two companies, Debricked, the company me and some friends founded about 4 years ago, and Elastisys, a company based in northern parts of Sweden, as well as partly in Lund as well, where we both collaborate and have customers within the security space and help them track and manage their security vulnerabilities. At Bricked, I work with data science mainly, but also research, and recently expanded my role to become the head of engineering as well. But we've all heard for the recent years about the threats of open source vulnerabilities and how that has exploded in terms of the amount of vulnerabilities, the usage of open source, and as well the criticality of those vulnerabilities. In the cybersecurity space, Log4Shell did not go under the radar for anyone. And we actually started this project a bit before Log4Shell, but realized its importance of correctly and more accurately managing your open source vulnerabilities after that particular event. But for the developers, this has become something that takes a lot of time and can not be always such an accurate process as you would wish. Developers and security experts, you can experience something like alert fatigue, where they are overly alerted of security vulnerabilities, and you end up not using the tools that your company is leveraging to actually manage these things, and you end up not getting things done within this part of the security stack anyways. And we call this the cry wolf paradox of security scanners. This typical large list of vulnerabilities may be a good first step of knowing what you have in your application, but actually managing that risk becomes quite tricky when you don't know what you're actually affected by and how you're affected by a particular security weakness. And the main part that we wanted to tackle with Arvos is the poor contextualization. So you know that you have a vulnerability in one open source component, but how are you calling that vulnerability? Are you actually calling that vulnerability, and in what type of environments? And I recently contributed this diagram to the Linux Foundation, where there's a way to reason about vulnerabilities in open source. And especially the false positives in open source. So we're looking at, first, are you using a vulnerable component? You can have false positives in that layer. Then, are you able to call the vulnerable code of that particular component? So typically static analysis, and you use something like call graphs to actually find that out. And then the third layer is what Arvos is targeting. Is it being executed in a critical environment? And there are two parts to this problem. One is what part of the open source project that have a vulnerability is actually the vulnerable functionality. We want to figure that out as part of Arvos, and that's where Debricked came in and contributed that with our vulnerability scanners and static analysis expertise. So here we have an example of the Java project called Netty, which has a couple of different vulnerabilities. Some of those vulnerabilities affect their web server. And some other of their vulnerabilities only affect their decompression functionality. And in Arvos, we actually developed two engines. One to find out which functionality is the vulnerable part of the open source. And then Elastisys contributed the functionality to actually track executing code in the critical environments to see if that code is being called. And here's where the AI part comes in, because it can be quite tricky to find out actually which part of an open source is the vulnerable part. So we use static analysis, build syntax trees, and have an AI engine to find what parts of the open source is the vulnerable part. And in the end, this can be used. We have developed a proof of concept with this through GitHub Actions. One of the main things that when we did our user studies together with our industry partners in this research project is that this should not impact performance. The willingness to install runtime agents in your critical environments is very low usually, even with like something like sidecar containers in a Kubernetes clusters, etc. So we pivoted the project to, rather than targeting running applications, we were targeting CI systems. Because their performance is less critical, and we can still get many of the benefits that, of the things that we have developed. So here you can see an example of where we are running normal tests, the test suite of a Java or a Python application this is, and we're hooking into the Linux kernel and understanding what software is executing. And can see if any of your tests or however you'd like to run your application in a CI environment actually trickles down to vulnerable functionality in the open source code that you use. So then you know that you are completely sure that this is the call trace to vulnerable functionality in this open source function. And if there's no call path to the vulnerable open source, then those should probably be prioritized less. I'll be outside here and be able to show you a demo. The tracking part of this is completely open source under an Apache license. I encourage you to find us at arvosdev on GitHub, where you can find our database of vulnerabilities and our tracking system. Thank you very much.
Thank you very much.